Okay, so from the top, factor. That is the first thing we got. And what does factor mean? Well, things are made up of factors. Things that you multiply to get things. Like factors for 8 are 1, 2, 4, and 8. I multiply 1 times 8 to get 8 or 2 times 4. So those are all factors of 8. 6. Factors of 6. 1, 2, 3, and 6. So if I look at something like 6x plus 8 and I consider the factors, 6x, that would be 2 times 3 times x. And 8 would be 2 times 4. So then I look to see what factors they have in common. 2 and 2. So that means I can pull a 2 out and then look at what's left. 3x plus 4. Those are common factors and I can pull them out. So when I say factor, in essence, that's basically what I'm looking for. I'm also thinking about if I have something with letters, oops, let's say not 5. 5 isn't going to work. So let's say 10x plus 25. I think about what two binomials did I multiply to get this trinomial? Well, in this case, it ends up being x plus 5 times x plus 5. X times x is x squared. X times 5 is 5x. 5 times x is another 5x. And then 5 times 5 is 25. 5x plus 5x is 10x. And thus, there is my polynomial, my trinomial. I multiply x plus 5 times x plus 5. So those would be the factors of x squared plus 10x plus 5. So I'm able to factor this polynomial to two smaller ones. Well, I'm going to do the same things with these two polynomials. Or polynomials, trinomials means the same. It means the same things for this. So anyway, I look at this and I think about what two things do I multiply to get x squared? Easy, x and x. Then I think about what two things do I multiply to get 8? Well, it's like I said, either I got 1 times 8 or I got 2 times 4. Well, whatever factors that I pull out or use, they also have to add together to give me 6. Well, 1 and 8 added together is 9. 2 and 4 added together is 6, so my factors would be 2 and 4. So now I look at the signs. If the sign for the last number is positive, that means both of my signs are the same. Then I look at the middle sign, and the middle sign is minus. That means both of these are minus. And that's it. Now, if I multiply this, x times x, that's x squared. X times a negative 4, that's negative 4x. Negative 2 times x, that's a negative 2x. And then negative 2 times a negative 4, that's positive 8. Negative 4x and negative 2x combine to be negative 6x. And looky there. Those two things multiply to give me this. So these two things are factors. So now I look at this one. This one I'm going to do what's called the AC method. The AC method, I need to recognize that this trinomial is in the form of ax squared plus bx plus c. Okay? And then I look at what a is, what b is, and what c is. Well, a is 6. A times x squared, 6 times x squared. B is 11. B times x, 11 times x. And then c is just 4. So now the AC method says I draw me an x and I take a times c and then put b here. So a times c, 6 times 4, that's 24. B is 11. So now I think of what two numbers do I multiply to get 24 but add to get 11. Now I could add or subtract. All right, but because there's two plus signs here, I know I'm just adding. If I was dealing with something that had a minus sign here, I might think that I was subtracting. So anyway, 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. Those are my factors of 24. Well, 3 times 8 add together to give me 11. So I'm going to put an 8 right here and a 3 right here. Honestly, it doesn't matter which side you put them on. So now I'm going to rewrite my equation, but replacing the 11x with 8x plus 3x. So 6x squared plus 8x plus 3x plus 4. Now I'm going to group these pairs together and then I'm going to factor. I'm going to look to see what these two terms have in common if I break them down. Well, 6x squared is 2 times 3 times x times x. 8x is 2 times 4 times x. I look to see what they have in common. A 2 and an x. So that's what I do. I pull out a 2x. And then I see what they have left over. 3x and 4. So now I factor 3x plus 4. Well, there's nothing that they have in common. 3x is 3 times x, and 4 is 2 times 2. Or I could say 3 is 1 times 3 times x, and 4 is 1 times 4 times x. So I just use 1. So I say I pull out a 1, and I keep 3x plus 4. So when I look at the numbers that are in my parentheses, they should be exactly the same. So now I write down the two numbers that are in the outside of the parentheses, 2x plus 1, that is my first binomial, and then I write down the numbers in the parentheses, 3x plus 4, that's my second. Factors, if I multiply these two things, I get 6x squared plus 11 plus 4. So now, simplifying these rational expressions to lowest terms, and I'm specifying the excluded value. So I've got x squared minus 25 over x squared minus 3x minus 10. More factoring. All right. So x squared minus 25. That's the difference of squares. So that factors to x plus 5 times x minus 5. And then I've got x squared minus 3x minus 10. Well, I'm going to give myself two parentheses. I know that x times x gives me x squared. So what two numbers do I multiply to get 10? But when I subtract them, see, notice I'm saying subtract because this is a minus sign, I get 3. Well, 10 is 1 times 10 or 2 times 5. Well, 2 times 5. 5 minus 2 is 3. So 5 and 2 are my numbers. Now, when this sign is minus, I look at the middle sign, and that sign goes to my highest number. Well, I've got 5 and 2. 5 is the highest number, so 5 gets the minus sign, and 2 gets the plus sign. So now that I've got this factored out, I'll look at the denominator for my exclusions. The denominator for my exclusions. So I've got x minus 5 equals 0, and x plus 2 equals 0. So let me make sure I'm perfectly clear. Exclusions, okay? The word means something that I can't use. Well, variables, the almost very definition says that I get to pick whatever number I want and plug it in. Well, if I'm dealing with a fraction or a ratio, something that has a numerator and a denominator, the denominator cannot be 0. I can't choose an x that would give me 0 in the denominator. Well, if I look at these two binomials that are in my denominator, if x equals positive 5 or if x equals negative 2, I get a 0, which the other factor times 0 is 0. Then I get 0 in the denominator. I can't have 0 in the denominator. That means when it comes to what values of x that I can use whatever numbers I want, except for 5 and negative 2. So those are excluded from the list of numbers I can use. Okay, And then finally, because the problem says simplify each rational expression to its lowest terms. So I can't simplify until after I check my exclusions. So once I check my exclusions, this and this cancel each other out. So my final answer is x plus 5 over x plus 2. Now the thing is, before I got here, I had these two binomials in my denominator. Even though it cancels off, see, the thing you got to remember is if I go back to my original equation and I plug in 5, I get 0 in the denominator. It doesn't matter that my reduced fraction looks like this because 5 put here wouldn't give me 0. It matters that at the beginning, the original problem, if I plugged in 5, I get 0. So because the original problem, 5 for x or x equals 5 gives me 0, I can't use 5. So that's why I do my exclusions before I cancel off. So here's my reduced fraction. There are my exclusions. So then we've got 4. It's 3x cubed minus 75x over x squared plus 10x plus 25. So the first, the numerator, I look and they have some things in common. This is 3 times x times x times x. This is 3 times 25 times x. So I can pull out a 3x and be left with x squared minus 25. And in my denominator, I think, okay, what two binomials give me this right here? Well, x squared is x and x. 25, what two numbers do I multiply to give me 25? When I add them, I get 10. That's 5 and 5. Both my signs are plus, so both of them are plus there. So what are my exclusions? I've got x plus 5 and x plus 5. So x plus 5 equals 0. Subtract 5 from both sides and get x equals negative 5. Well, just because it's there twice, it doesn't matter. I don't have to write it twice. So my exclusions. Exclusions x cannot equal negative 5. So now that I got that, now I can go to reducing. So where I was at was 3x times x squared minus 25 over x plus 5 times x plus 5. Well, what is this? That is the difference of squares. So that's 3x times x plus 5 times x minus 5 over x plus 5 times x plus 5. And then I can cancel those off. And so I have 3x times x minus 5 over x plus 5. And that's my final answer. That's my final answer. So the next thing I have is determine the domain. The domain is just a fancy way of saying what values can I plug in for x? What range of values can I plug in for x? Well, when I'm looking at a problem that's a fraction, you focus on the denominator. So trying to find the domain, you focus on the denominator. So I take that denominator, x squared plus x, and I remember that a fraction, when I'm dealing with variables, okay, I cannot have 0 in my denominator. So I set the denominator equal to 0. I look for what values will give me 0. Well, when I've got a problem that's got variables in it, I probably need to factor. So I look at this and think about what are these things and what can I pull out? Well, x squared is x times x. X is just x times 1. So I'm going to pull out an x and be left with x plus 1 and set that equal to 0. So now I have a variable out here, and then I have this thing right here that has a variable in it as well. So I think what values of x can I what values of x, if I plug them in, are going to give me 0? Well, it's kind of simple to see that x plus 1, if I got x equals -1, I'd get 0 there. We'll see. What's important to notice that may not be as easy to see is this x right here is on the outside all by itself. It's being multiplied by this binomial here. So if I choose 0 for x, I'm going to get 0 times 0 plus 1. It doesn't matter that the inside is 1. It matters that the number on the outside is x, and x is 0, so then I get 0 times 1, so that'd be 0. And then obviously x plus 1, if x is -1, -1 plus 1 is 0. So when you're trying to find your domain, you're looking for your exclusions. Okay, it's the same. It's pretty much the same thing, except domain you get all fancy and you just say the domain is all real numbers except, like an exception, except for 0 and -1. So that's my answer for, what is that, number 5? So then let's look at number 6. Number 6, 23x over x squared minus 16. X squared minus 16 is the difference of squares. So I'm going to factor that. I got 23x on the top, and I've got x plus 4 times x minus 4. So I know what my exclusions are. My exclusions are -4 and 4. It's just what values of x make that 0. Just so you're understanding, you set those equal to 0 and you solve the little equation. So those are my exclusions. So then that means that my domain is all real numbers except for 4 and -4. So that's number 6. Take a quick spot check back slowly. And then we go here. And we're looking at number 7. Number 7 is still determine the domain. So x to the 4th power minus 1 over x squared plus 1. Now, let's talk real quick over to the side. X squared minus 25, right? If I set that equal to 0, I add 25 to both sides. I get x squared equals 25. Now I can do that. If I take the square root of both sides, I get x equals plus or minus 5. I can do that. But see, if I have a problem like x squared plus 25, let's put that up here. If I have a problem like x squared plus 25 equals 5, I subtract 25 from both sides, and I get x squared equals -25. I take the square root of both sides, and I got a negative under the square root. So we know what that means. That means I separate that. So that's the square root of -1 times the square root of 5, or 25, excuse me. And then I know that that gives me an I. Well, we're talking about real numbers. So that's not an option. I'm looking for what exclusions, what things can't I plug in for x? Well, I'm only dealing with real numbers for this domain. So because x squared plus 1 can't be factored without using I, and I can't set it equal to 0 and get just a straight value without using I, I is an imaginary number. My domain is all real numbers. So that's number 7. So that was determining the domain. Domain, I just focus on the denominator. Now, next you got determine end behavior. Determine end behavior. So there were 3 instances that we dealt with. We dealt with what would happen if you ended up with x, what would happen if you ended up with 1 over x, and some power. So it could be 1 over x squared or 1 over x cubed. It could just be x to the third or x whatever. But the bottom line is it's just x with some exponent. It's 1 over x with some exponent. Or I end up with some constant because my x's cancel each other off. There were 3 instances. I'm going to go over each one of those instances right now. So 8. 8 is 3x minus 6 over x plus 2. So anyway, when looking for end behavior, okay, I'm thinking about the variables that I'm plugging in for x. You can think about it like a number line. I'm going to be plugging in either negative values, so I go to the left and I just keep plugging in negative values, or I'm going to go to the right and I'm going to be plugging in positive values. If I keep plugging in negative values, I just say that I'm putting in, x is approaching negative infinity. Because as I go here, the negative numbers end up getting, I know it's a little crazy to say, but bigger, even though negative numbers don't really get bigger. So -1, -5, -10, -100, -1000, and so on and so forth. And then the same going the other way. 1, 5, 10, 100, 1,000, 10,000, whatever. So there's the negative infinity side, which is the negative side, and then there's the positive infinity side, which is the positive numbers. So I think about what effect does it have on my function when I plug in more negative numbers? What effect does it have on my function when I'm plugging in positive numbers? So the way I do that is I look at my function and I focus on only the variables that have the highest exponent for the numerator and for the denominator. Well, this one's easy. There's only 3x and x. And I'm going to say this again. The numbers 6 and plus 2, I forget about them when I'm determining end behavior because in the big scheme of things, this -6 is not going to have any effect on what my numerator is. If I picked x is 2, so x equals 2, that would have a big effect because 3 times 2 is 6. 6 minus 6 is 0. Oh my gosh, that has a big effect. It made it 0. But what if I picked x equals 10? 3 times 10 is 30. 30 minus 6 is 24. Now I'm just dealing with a positive number. Well, what if I pick x is 100? So then that's 3. If I pick x equals 100, that's 3 times 100. That's 300. 300 minus 6 is 294. That 6 didn't really make a difference. Between 294 and 300, it's not that much difference. Well, wait a minute. What if I pick 1,000? 3 times 1,000 is 3,000. 3,000 minus 6 is 2,994. That 6 doesn't make that much difference. So when I'm thinking about end behavior, what happens is I'm plugging in more and more numbers, bigger or smaller numbers. I just focus on the the um the variable that has the highest exponent. Well, I only got those two. I've got 3x on top and x on the bottom. So now I just think about it. Well, 3x divided by x, well, the x's cancel each other out because a fraction is just a division problem. So then what am I left with? I'm left with 3. So what that's leaving me with is that when I'm plugging in, so x, for x, as I'm plugging in more negative numbers, right? I'm plugging in negative numbers. What's going to end up happening is my answer, which because we're talking about a function, we use function notation. So fx is my input. F of x is my output. So as I'm plugging in more negative numbers, my answer or my output is going to approach 3. Because the negatives, I've got an x on top and an x on bottom. Doesn't matter that they're both negative because the negatives cancel off. If I plugged in if I plugged in -5, I would get 3 times the -5 divided by -5. The -5s cancel each other out, and so do the negatives. So I'm still left with a +3. If x approaches positive infinity, so I'm just putting in positive numbers. It doesn't matter what number it is, it's on top and bottom, so it's going to cancel off. If I put x equals 10, 3 times 10 divided by 10, the 10s cancel off, and f of x approaches 3. And so that's my answer for the first one. Okay? And that situation is my variables cancel off. Next, I have 4x plus 1 over x squared plus x minus 6. Right? Well, again, all I'm going to do is focus on the highest powers of x. So on top, I've got 4x. On bottom, I've got x squared. Well, again, I've got an x on top and an x on bottom. So I pull out an x from the top and from the bottom, and I end up with 4 over x. This is my second possibility, that I have a constant on top and a variable on bottom. So the top doesn't change, but the bottom does. So let's take a little sidetrack so you can understand what's going on. I was going to use 1, but I'm not. I don't want to confuse you. So let's talk about 4. Let's say I got 4 over 10. That's my first choice. I picked 10 for x. Well, you know what? I'm going to pick 100 for x. No, I'm going to pick 10,000 for x. No, I'm going to pick a million for x. What ends up happening is the bigger x's that I pick, the smaller my fraction becomes. And it keeps getting smaller and smaller. But because this is 4, this doesn't change, I'm never going to hit 0, but I'm going to get really, really close. So when I have a constant on top and a variable on bottom, as my x approaches negative infinity, my f of x approaches 0. Even though the number is going to be negative, it's just going to approach, it's going to approach 0 from the negative side. And then what's going to happen as my numbers are getting bigger on the positive side? It's going to approach 0 from the positive side. So x approaches positive infinity, f of x approaches 0. So variable in the denominator, constant on top. The end behavior is it approaches 0 for negative and positive infinity. Now, I made a misstep on number 10. I forgot to put x squared. So it originally said x plus 3 over x minus 2. I'm going to change that to x squared so I can make my point. So I've got x squared plus 3 divided by x minus 2. So I'm going to forget about the constants and just say I've got x squared over x. Well, come on. So I've got an x down here that's going to divide out, and I've got 2 x's up there, so I'm going to get rid of 1 x. And so that's going to be x over 1 or just x. So when I'm looking at end behavior and all I'm left with is some power of x, and it works for when x is in the denominator too. I'm going to put an n there and an n there because it doesn't have to just be x. It can be x to the second power, x to the fifth power, x to the 12th power. It doesn't matter. The bottom line is the behavior is the same if whether the exponent is 1, 2, 12, whatever. So I get some power. In this case, I just get x. But the general case is that I got x to some power of n. What does that mean? Well, as x approaches negative infinity, which means on this number line, I'm just putting in negative numbers. -1, -5, -10, -100, -1000. f of x, my answer, approaches negative infinity. And then as my x approaches positive infinity, so I'm putting in positive numbers 1, 5, 10, 100, 1,000, 10,000, a million. F of x approaches positive infinity. As I'm putting in positive numbers, I'm getting positive numbers. And the bigger my numbers, the bigger my input, the bigger my output. So it's approaching infinity. So those are the three instances of determining end behavior. My variables cancel off and I'm left with a constant. So it approaches the constant. I've got a variable divided by, or excuse me, I've got a constant divided by a variable. So my functions approach zero. And then finally, I've just end up with a variable. And so as I put in negative numbers, my function approaches negative numbers. When I put in positive numbers, it approaches positive numbers. Boom, I'm done. Okay, so now let's look at consider the function 5 over x squared minus 4. So there's three things to consider, okay? There's state, the domain of the function. Then there's determine and behavior. And then finally, there's state any vertical and horizontal asymptotes. Maybe I should learn how to spell. Asymptote or asymptotes lines. State any vertical or horizontal asymptotes of the function. All right, state the domain. Well, what did we say a domain was? Well, you look at the denominator, x squared minus 4. That is the difference of squares. So that factors to x plus 2 and x minus 2. So then what does that mean? Well, that means my domain is all real numbers except for x equals 2 and negative 2. So now I need to determine end behavior. Well, let's see. I've got 5 over x squared minus 4. So I choose, in my numerator and my denominator, the highest powers of my variable. Well, the top doesn't have a variable. I got x squared in the bottom. So I've got a constant divided by a variable. So what do I know about that? Well, as x approaches negative infinity, f of x approaches 0. As x approaches positive infinity, f of x approaches 0. So my end behavior is it approaches 0. So now I got to state vertical and horizontal asymptote lines. So what the heck does that mean? Well, when I've got a graph, all right, and I think of, okay, what are the domain? The domain is the x's that I can plug in. So if I've got exceptions, they act like invisible guidelines that I can't use. So if my domain is all real numbers except for negative 2 and positive 2, those are my vertical asymptote lines. So my graph gets plugged, it cannot cross those lines. So I can have my graph that it does whatever over here, but it can't touch those lines. In between these two lines, I can do whatever I'm going to do, but it can't touch those lines. And then over here after it, whatever I want to do, but it can't touch that line. So that's the vertical asymptote. So your domain Um, tells you vertical asymptote asymptote lines. And now in behavior. In behavior tells me my vertical asymptote lines. So in behavior tells you vertical asymptote lines. So what do I know? Well, so for my answer, horizontal asymptotes, horizontal asymptotes. I've got x equals 2 and x equals negative 2. So for my vertical, oops, I'm sorry, I screwed up. First one is vertical, second one is horizontal. Sorry. So I just said domain does vertical. So my vertical asymptote lines is x equals 2 and x equals negative 2. So my horizontal asymptote lines is y equals 0. Remember, I'm talking about a coordinate plane. Left to right is x, up and down is y. Even though we were using f of x here or whatever, I can just state it like this. So vertical asymptotes, x equals 2, x equals negative 2. Horizontal asymptotes, y equals 0. So that just means that there is, a dotted line right here, and my graph can't cross it. So I can put my graph all up here or all down here, all up here or all down here, all up here and all down here, but it cannot touch the green or the red lines. So that's what I got for those. Got two more things. And then we can talk about this calculator thing. So, given a plus b over x minus c, name the effect of changing a, b, or c in the graph of f of x equals 1 over x. So I'm just asking for one out of the three. So you got three different things to choose from. So we've got a. What does a do? Well, a shifts my graph up or down. B, we can say this a couple different ways. We can say this a couple different ways. We can say it opens or closes my graph, or B stretches or constricts my graph. Just remember what I'm talking about. So if this is my graph, B would make these lines go smaller and smaller or wider and wider. Okay. And then C. C shifts my graph left or right. So it's just about saying one of those facts. Just put that nugget in your head, remember it, write it down. So given A plus B over X minus C, name the effect of A, B, or C. Well, there's the effects of A, B, or C. Now, last is the composition of functions. So we're going to let f of x equal x squared. And we're going to let g of x equal 3x plus 5. So I want you to find f of g of x. So what does that mean? Well, that means I start with g of x. Well, g of x is easy. It's 3x plus 5. So I'm going to put 3x plus 5 in here for my answer. So now I've got f of 3x plus 5. So now I'm going to write my function if x for f of x is x squared, f of 3x plus 5 means I'm going to have 3x plus 5 squared. And what does that mean? That means 3x plus 5 times 3x plus 5. So I got to do FOIL. So I got 3x times 3x, that's 9x squared. I've got 3x times 5, that's 15x. I've got 5 times 3x, that's another 15x. And then I've got 5 times 5, that's 25. And then finally, I'm going to have 9x plus 30x plus 25. So that's my answer. F of g of x equals that. So then next, I want to find g of f of x. So when it's written in this form, golf or g, the little o, but it doesn't really look like an o, f and then of x, that means I start with f. So I'm going to have g on the outside and f of x on the inside. It means the same thing. So f of x is x squared. So now I've got g of x squared. So wherever I have an x in my original function, I'm going to put x squared. So that's 3 times x squared plus 5. All I did was replace x with x squared. And then there's nothing to do there, but just rewrite it. 3 times x squared plus 5. And that's my answer. So that's f of g of x. This is g of f of x. So next, I want to find g of f of 2. Now, in all honesty, I could just go back to this problem and then plug in 2 because I've already did g of f of x. I already did g of f of x, right? I already did g of f, so I can just plug in 2. But for giggles, I'm going to start from scratch. So I got g on the outside, f on the inside. Let's put a 2 right here. So I'm going to look at f of 2. Well, f is x squared. So 2 is going to be 2 squared. So f of 2 is going to be 4. So now I've got g of 4. So now I go into g and I plug in 4. So I got 3 times 4 plus 5. 3 times 4 is 12. So 12 plus 5, that equals 17. So that's my answer there. So now I'm going to find f of g of negative 3. So now I'm going to put negative 3 in there. So, like I said, I'm going to write it like this again. So I'm going to have f on the outside, g on the inside. So g of negative 3, I go back to this. 3 times a negative 3 plus 5. 3 times a negative 3 plus 5, that's negative 9 plus 5, that's negative 4. Right? So I'm going to have f of negative 4. So I'm going to take negative 4 and plug it into f. Well, that's negative 4 to the second power. Negative 4 to the second power is positive 16. And that's my answer. Composition of functions. A function inside another function. Well, let's do another one that's not on there just in case. So let's find f of x. Well, I'm going to have f of x, and then I'm going to have another f on the outside of it. So f of x is x squared. And so then I want f of x squared. Well, f is x to the second power. So instead of having x, I'm going to say x squared to the second power. So x squared to the second power is x to the fourth power. And it works the same with g. If I find g of x, I've got g of x. So what's the first g of x? Well, g is 3x plus 5. So I'm going to have g of 3x plus 5 because that's my answer. So I'm going to say 3 times 3x plus 5 plus 5. All I did was replace the x with 3x plus 5. So then I distribute and I get 9x plus 15 plus 5. And those two I can combine, so I get 9x plus 20. And that's my answer for g of g. The last thing, the last thing, right, was use the calculator to graph the function, right, 4x minus 6 over 2x plus 5. So I turn on my calculator. TI Inspire CX2, and it's taking its sweet time to come up. Okay, so I go to that, and you've got your thumb that moves the mouse, and you have a choice of things to choose. You could choose to go to the graph, which is on the scratch pad B, or you could go to new and choose new. And then when you select new, it gives you the option to add a calculator, add graphs, add geometry, add. So then you would just go to add graphs. When you add graphs, you're given a coordinate plane, but then you're also given an f of x equals. And that's all you got to do is type what you see on f of x equals. So there's a parenthesis button, I'm going to push parenthesis. And so I'm going to say 4x, what is that, minus 6, and then I'm going to push the parenthesis button, say divided by, and then I'm going to push parentheses again and say 2x plus 5, and then parentheses. You press enter, and it graphs your graph for you. That's it. That's all you need to know. Now, if you choose the graph option, so you're looking at your black screen, and you got scratch pad, and you press graph, it's going to kick you to a little whatever. It's going to kick you to some screen. It may have a graph or it may not. If you push the menu button and you go down to option 3, it says graph entry or edit. You choose that. Then it gives you a bunch of options. You want the first option, function. You choose that. It does exactly what the other side did. It gives you an f of x equals, and then there you type in your graph. And that's that. All right, that's everything. No interruptions and all this blah, blah, blah. Hope that was helpful.